All right. Welcome back to Geography 101. This is Chapter 1, Part 3. And let's continue on. Talk about Wallace's line. So, Wallace was a scientist in the 1880s who was in this area called the Malay Archipelago, which we currently call Malaysia. And he was going through this area and he was categorizing animals and plants. And so he would basically go into an area and he would write down descriptions of all the animals and plants he saw, different trees, different birds, different mammals, insects, amphibians, fish. And what he noticed was that animals on this side of the line tended to be very similar. In fact, animals on this side of the line tended to be very different. And if you think about Australia, right, think about the animals of Australia. Kangaroos, which have pouches and hop, right? You have the platypus, which is a mammal that actually lays eggs. You have very different plants and animals. And what he noticed was that basically on this side of the line, right here, much different than here. And he couldn't quite figure out why. But what he said was that this was a biogeographical zone of transition. In other words, right here, something happens to change or allow for different plants and animals to evolve, right? That these were African plants, or I'm sorry, Australian plants, and these were more Asian plants. And what is interesting, that he didn't quite know why, okay? What happens is, we now know, and we use this today as evidence of plate tectonics. This is part of the Australian plate. And if you think back to that map, let me go back real fast here. So right here's the Australian plate. There's that line. It's actually the same line. Here's the Eurasian plate. 55, 60 million years ago, Australia was right over here. It was nowhere near Asia. So over time, the animals that were in Australia evolved and stayed separate. So much so that even though Australia is now right next to Asia, the plants here had a much different course of evolution, and so appear to be very different. Let's go back to where we are. So that today we now know this is actually the plate boundary right here. So he was actually discovering that without realizing it. Weber's line, very similar, very similar. But the world today is humanized, and what we mean by this is that humans have continuously moved, and we're one of the only species that lives on every continent. In fact, we are the only species that lives on all 7 continents, with the exception of 2 others. There are 2 other types of animals that live everywhere. And I'm going to let you think about that, and then I'll tell you what they are in just a little bit. But because of our movement, there's been a lot of environmental impacts, okay? And we see this in the fossil record. Competition between hominid groups for resources led to what we call the Pleistocene overkill. And what this means is the Pleistocene refers to a period of time about roughly 10,000 years ago. Whenever humans moved into a new part of the world, like Europe or Asia or Australia or America, we find that within 1,000 years of humans arriving, large animals go extinct. Pleistocene overkill. So megafauna, large animals. We also find these sites where there's just tons and tons of dead large animals. So a good example is humans arrived in North America about 12 to 13,000 years ago. About 10,000 years ago, we find these huge deposits of dead horses. And what happens is humans were hunting these horses. They basically found a way to easily hunt them. They were large animals. They just basically ran them off a cliff, and they would fall over and die, and then they could butcher them at their own free will. It sounds horrible, but I mean it's a very efficient way to hunt. But what happens is this competition for food basically gets rid of large animals in almost every part of the world. This graph just kind of shows you that as humans arrive, the extinction rates for large animals go up. Prior to humans coming to Australia 60,000 years ago, there were kangaroos that were 8 to 10 feet tall. They were gone within 100 years of people coming by. So I asked you guys a question. I'm going to come back to that. There are 2 other animals that live everywhere that humans do in the world. And the first one is rats. Wherever humans go, rats have followed. Rats have evolved to live off of our trash and do quite well. And the second one are dogs. And dogs we bring willingly. So climate change. You've probably heard about climate change in the news on many current events. We are going to touch on it a little bit in this class. I don't see how we can't. We're not going to focus on it as much as I would in my physical geography class. But let's just say this, that climate is not weather. Weather is what's happening right now. So today it's hot, tomorrow it's rainy, and on Saturday it's going to be 75. That's the weather. Climate is, in the summer in Chicago, it's hotter than the winter. Climate is your personality. Weather is your mood. So when we talk about climate change, we're not talking about a bad storm. We're talking about, gradually getting warmer or colder or wetter or drier. And over our history, Earth's climate has dramatically changed. At some points, it's been as much as 25 degrees warmer than it is now and no ice. And there have been some points where the entire planet has been covered with snow. In the last 1,000 years, we've actually had what's called a medieval warm period. Roughly to about 1,000 years ago, it was much warmer than normal. Right about the year 1300 to 1600, we had a very long cold snap, about 200 years. But what we have noticed in the last 100 years is that temperature around the world is rising slowly. And it's mainly due in part to anthropogenic climate change. In other words, the factors that are causing this to change are caused by man. When we look at the Ice Age, we look at the medieval warm period, we don't know exactly what caused it. We think we have an idea. It might have been changes in the sun's output, changes in Earth's orbit that we talked about. But when we look at the last 100 years, what are the things that could change climate? The only things that can change climate that we can find evidence for are things that are the cause of man. And the main cause is greenhouse gases like carbon dioxide. We've noticed that since the 1800s, the amount of CO2 in the atmosphere has gone up dramatically. 1880, we go from an average temperature right here of 57 degrees and an amount of carbon dioxide about 300 parts per million in the air to today. In fact, this graph is outdated. We are over 400 parts per million. In fact, carbon has never been higher in history than it has been in the last so many years. And what we've also noticed is that going back as far as we can tell, about 800,000 years, as carbon increases, so does temperature. And this just shows you the average temperature of each year. And it varies, but generally speaking, the trend matches the CO2 concentration. Now, how does that affect us? How does that affect us currently? Well, currently, I can think of a great one. Last May, this May, was the wettest May since we've kept records in Chicago for about 120 years. Last year was the second wettest May. 3 years ago was the third wettest May. So what's happening in Chicago is our early summers in May are going from being warm and sunny to being cool and wet. So that's a thing that I see happening right in front of us. What are some other things we see? Around the world, glaciers are melting. Animals are shifting their ranges of where they live. We see the extinction of animals increasing at a rate that might become the possible sixth great extinction. We currently see stronger storms and droughts. Ecosystems on land and in the oceans are much, much more threatened. And the Arctic amplitude, climate change is happening twice as fast in the poles than anywhere else. So how do we accomplish this in the future? Well, we can adapt. In other words, adapt means that we can't stop climate change, right? So we have to figure out technological solutions, ways to keep us cooler, methods to grow crops in different climates, ways to account for all of these aspects, right? Or we change our behaviors. So we don't use as many cars. We can't afford to have as much air conditioning, or we have to live in air conditioning year round. I think 30 or 40 years ago, it was unusual to have air conditioning in your house in Chicago, where now it's commonplace. And in fact, if you think about Las Vegas, Nevada, without air conditioning, that town wouldn't exist. So that adapted to the desert. The other option is mitigation. Maybe we can slow climate change, or we can alleviate the demand. Maybe we can lower our carbon footprint, or how much damage we do to the atmosphere. We can lower emissions. one of the interesting side effects of this COVID pandemic lockdown is that around the world, so many people stopped working and so many people stopped driving that this year we're going to release on average between 8 to 10% less carbon than the year before. That's the first time we've seen a drop in 200 years. So that's going to be interesting to see how that plays out. All right, so we're almost done. Every chapter that we do for that starts off with the outline and it ends with these chapter summary notes. These are really good notes. I'm not going to read these to you, but these are things you can go back to with the PowerPoints to study for your tests and your quizzes. They're basically some PowerPoints of things we talked about. Okay? So, next time, make sure you check with the syllabus. Make sure you check on D2L. If you have any questions, comments, concerns, as always, give me a call, send me an email. I guess you really can't call me because I'm not giving you my home cell phone number, nothing personal. And I will see you in virtual class next time.